Welcome, guys. I want to walk you through assignment number 5. It is a simulation online. If you have any trouble with it, just give me an email and we'll get together on a Google's Meets and we can share our screen and figure out how to do it. On this assignment, there are 2 attachments. One is the link to the simulation and the other is a slideshow presentation. And I'm going to go over that slideshow presentation with you now and kind of walk you through the simulation. The rates of reactions, you should be familiar with these types of factors that influence the rate of reaction. There are some notes that I have put together for you that you could use, so just review those if you need to. Today, we're going to kind of make sure we review those factors that affect the rate of reaction and explore applications and use this simulation to visualize the reaction. In this graphic here, I have a beaker of these purple, let's say they're the reactant A, and they are changing with time into the product B, which are green. And if you look at this graph, you can see that the number of molecules that are purple of A are reducing with time, and the number of molecules of products start at 0 and then they increase with time. Today we're going to use this simulation, and you can click the link right on the slideshow, or you can click the link that was attached to the assignment. We're going to run the kinetics experiment at a conversion rate. I'm going to do the example at 50%. You're going to do it at 20%, and then again at a unique rate of your choosing. So if I take a look at this, again, I'm just going to click the link that's right here, and it looks sort of like this here when you open it up. We're going to work on the tab that says kinetics. You can also click right here. We'll do equilibrium and Le Chat's another time, but right now we're going to work on this kinetics one. So if you read the introduction, it says it models a time-dependent one-way reaction at a constant rate, the percent of A converted to B. So click on the kinetics tab, and we're going to use this little part right here to change the rate. So if you click right here, you'll be able to pick a rate of reaction. So I'm going to pick, for my example, 50. And the numbers are on the slideshow, so you can enter them. You might want to open the slideshow and this at the same time so you could toggle back and forth. There's going to be a graph here that'll display the data, and there's a visual right here that you can see there's 100 molecules of A and no molecules of B. So again, I'm going to toggle back to this screen. This is where the rate dropdown is, and we're going to enter our data right here. This is the data that we're going to enter for the 50%. I'm going to go ahead and do that with you so you can familiarize yourself with the model. First, you want to select the 50%. You're going to enter the first number, 50. I want you to notice why and how the numbers are changing as you enter them, because you will be calculating the values for a different rate. I put some hints down here on how you could calculate them. If we're using the 50%, in your calculator, you use that percentage in a decimal form. So let's see if we can kind of go through that on the simulation. So again, I picked a rate of 50%, and I have 100 molecules. 100 molecules times 0.5, that's 50% in decimal form, is 50. I enter that number and I hit equal. You will notice it subtracted the 50 molecules and it added the 50 molecules to B. And you can actually see that happening here, and it graphs it for you. Now, if I do 50 molecules times that 0.5 for 50%, and I enter that number, you can see it'll do a next step. If I take the 25 and I multiply it by 0.5 for 50%, I get 12.5. When I go to enter 12.5 in this simulation, it will not let me enter it. It only enters whole numbers. You can try the whole number just above or just below. So if it was 12.5, I might try 12 or I might try 13. One works, one doesn't. Just do a little trial and error. So now I have 12 molecules left, and the rest have changed to molecules B. So 50% of 12 is 6, and 50% of 6 is 3, and 50% of 3 is 1.5. I can't enter 1.5, so I'm going to round it. Sometimes I try to round to 1, doesn't like it, so I'm going to try to round to 2. There it is. 50% of 1. This time let me put in the 1. 50% of 0 is 0. And when you put in the 0 the second time, this little kinetics debrief comes up. And when you click on it, it will give you some additional information that you might need to know for some of the questions. So I'm going to go back to this sheet right here on our slideshow. And you'll notice it says a worksheet is linked right here. Again, if you're having trouble with the calculations, check down here. But also on that linked worksheet, I have set up some of the calculations for the rate of conversion of 20%. So you can use this to kind of guide yourself as you need to. You're going to have to also do it for experiment 2, a rate of your choosing. When you finish the 20%, take a screenshot, then try a percentage of your choosing and take a second screenshot. You can upload the screenshot. So again, I'm going to go back to the simulation. I'm going to change that percentage. So this time I'm going to choose 20%. It'll reset it for me. I take 20% of 100, and that's 20. And then I take 20% of 16, and that is, 20% of 80 is 16. And then I take 20% of 64 is 13, 20% of 51 is 10, 20% of 41 is 8, 20% of 33 is either 6 or 7. I'll try 6. It didn't work, so I'll try 7. It's actually a decimal in between 6 or 7, but you want to kind of round it as best you can. So 20% here is 5, 20% is 4, 20% is 3, 20% is about 3, 20% is 2, 2, 2 is too many, so I'm going to go to 1, 20% is 1, 1, 20% is 1. Now 20% of 3 is less than 1, but I'll round it to the whole number. And 20% of 2 is actually 0.4, so I'm going to have to round it down. And again, when I get to 0, I get this kinetics brief. You would take a screenshot of this one right here, and that would show me that you did the 20%. You want to go back and make sure you do a second experiment at your choosing and then upload both of those. On page 3 of the linked worksheet are some questions. We'll do those on a Google form next class. There's also some notes there on page 4 to 6. If those notes look unfamiliar with you, I did put an optional video clip and an optional reading. And then page 10 has some review questions that we'll do next class. So again, that worksheet that I was talking about kind of goes over the same information. It gives you an opportunity to kind of work out some of the math on paper if you need to. You can certainly just do the math on your phone or calculator and enter it directly and then upload the screenshot is fine for me. When you finish and you get that 00, you get that little kinetics debrief. Make sure you read that. You could preview some of these questions that will be on next class's Google form. And then there's some notes about surface area, concentration, pressure, temperature, a catalyst, and of course some other factors that might influence the rate of reaction. And then finally, we have some practice problems here, 1 through 5. We're not doing these today, but you can certainly review those in advance. This is an example of a reaction rate poster that I did last year with my classes. I don't think we're going to do this year, but I do want you to kind of just take a look at it. If it looks unfamiliar, you do want to go back and check out those notes on page 4 through 9 of that linked worksheet. It's linked in the slideshow. And just to kind of check yourself, if you sketched this graphic and I asked you to label the reactant and label the products. See this red line here? This one is the reactant. As time goes on, it's being reduced. And the blue line, this one is the product. As time goes on, it is being produced and increases. And then suggests 3 methods to increase the rate of reaction. Again, you should be able to do that from some of the classwork we've already done. Next, I'd like you to watch this little video clip about visualizing equilibrium. It's about 6 minutes. And then I have a second one about reversible reactions that's relatively short as well. We'll be talking about equilibrium and reversible reactions in the next class, and we'll redo that kinetic simulation, but we'll click on the equilibrium tab next time. Think about these questions as you're reviewing. What eventually happens in an equilibrium reaction? What is that meaning of equilibrium? And what does that little back and forth symbol mean? When we talk about these things, we're going to be talking about dynamic equilibrium. And there's several different types of equilibrium. We're going to be focusing on this chemical equilibrium, but just to quickly review, things like boiling point is a phase equilibrium. The same number of molecules are evaporating as condensing. Things like saturation is what solution equilibrium. The same number of molecules are dissolving as recrystallizing. So the positive ions are being surrounded by the negative oxygens, and the negative ions are being surrounded by the positive hydrogens, but just as many that are dissolving are crystallizing back out when a solution is saturated or at equilibrium. We're going to be talking about chemical equilibrium, which has to do with reversible reactions. And this is a dynamic situation. The number of reactants that are changing into products are the same as the number of products that are changing into reaction. Even though it looks like it's at a status quo, that it's kind of leveled out, whether there's more products or more reactants depends on the conditions for the equilibrium, as we'll see in Le Chat's principle. But even though they've kind of leveled out, I want you to realize that they're dynamic equilibrium. It just means the same number are going forward as going backwards. Make sure you answer the attendance question. Complete the kinetic simulation twice. Do it at 2 different rates and screenshot each rate to upload to the Google Classwork assignment number 5. Watch the reversible reaction equilibrium videos in preparation for next class. Next class, we'll do the questions and then we'll do the equilibrium simulation. Thank you guys for keeping up with the work. I really appreciate it. Just email me if you need to get together to discuss anything. Certainly do a Google Meets, and hopefully we'll go forward from here. Thanks.